Hello, and today we are looking at the product rule, which is a method for differentiating functions. It's part of the A-level and IB mathematics syllabuses. The product rule, again, is used to differentiate the product of two functions. That's when you have a function multiplied by a function. So if our function y is a product of the function u and a product of the function v, that is u times v, then dy dx is equal to v multiplied by the differential of u plus u multiplied by the differential of v. That's v to u dx plus u dv dx. It looks quite scary, but actually using it is reasonably straightforward. So for example, here's a product multiplied by a product. 2x times a bracket. I'm going to split them up into u and v. Our u product is 2x, and our v product is our bracket 3 plus x to the power of 4. I'm going to differentiate each one separately and plug them into the rule. So the differential of 2x is simply 2. The differential of v is going to be 4 times your bracket cubed. It's kind of using the chain rule in my head for that one. So our rule, v du dx plus u dv dx. Simply look at what you've written down and put the bits together. So v times du dx is 2 lots of 3 plus x to the power of 4, and u dv dx, now be careful here, there's a 2x times 4, which is 8x, and then your bracket 3 plus x cubed. And if your question says differentiate it, boom, you're done. It may go a step further and ask you to simplify it though. To simplify that, we factorize it. There are two things these terms have in common. They have a factor of 2, and they have this big bracket. Now, sometimes this isn't easy to see, so I'm going to try and simplify it a little bit. If I call 3 plus x a, and I rewrite my dy dx in terms of a, you don't have to do this step, but it is sometimes a bit easier. Then my first term becomes 2a to the power of 4 plus 8x times a to the power of 3. Now that's easy to factorize. They have a factor of 2 and a cubed in common. If I take out 2a cubed, what's left is a plus 2 plus 4x. At this point, substitute 3 plus x back in for a. So 2a cubed becomes 2 times 3 plus x cubed. And in my bracket, a plus 4x becomes 3 plus x plus 4x. The 3 plus x being, of course, a. And your last step is simply to simplify it. So inside the last bracket, 3 plus x plus 4x becomes 3 plus 5x. And the question is as simplified as fully as possible. Again, it may ask you to simplify it. It may not. Now, the product rule can also be used to differentiate square roots. This is, again, a product multiplied by a product. Our first product is x squared. It's very easy to differentiate that. You should get 2x. The square root one, if you rewrite it as 3x minus 1 to the power of a half, it becomes a lot easier. You simply differentiate that any way you like. I would use a variation of the chain rule to do it, or a half times the x coefficient. So a half times 3, 3 over 2, by your bracket, then a half subtract 1 as your power is minus a half. So you've got your u, your v, your dv dx, and your du dx. And again, simply stick them in your product rule. So dy dx is v times du dx. So 2x times 3x minus 1 to the power of a half plus u times dv dx. Now, x squared times 3 over 2 should be just 3 over 2 x squared, and then stick your bracket in as well. So 3x minus 1 to the power of minus a half. If again your question says differentiate it, you're finished. If it says simplify further, then I would simplify it by evaluating each of the powers. What I mean by that is, what does a power of a half mean? And what does a power of minus a half mean? Simply write it in a different format. So in this case, dy dx is still going to be 2x times 3x minus 1 to the power of a half, but the power of a half means it's a square root. So it's 2x times square root 3x minus 1. The next one is very similar. Minus a half means it's going to be a bracket, negative power, not a bracket, sorry, a fraction. A negative power means a fraction. 3 over 2, x squared on top. This whole bit is on the bottom, square root 3x minus 1. Now we can also, of course, differentiate trigonometry using the product rule as well. In this case, I'm going to set my v first. I'm going to have v is cos 5x. So dv dx. If you differentiate cos, you should get minus sine. So minus 5 sine 5x. That was very straightforward. My u term in this case is going to be 4 sine squared. Now, to differentiate that, I'm going to use the chain rule again. I'm going to use chain rule within a chain rule, simply because I've got sine squared. Squared means sine times sine. That's a function times a function. I can use the chain rule to do this. If I write it as y equals 4 u squared, where u is sine x, then I can differentiate each part and stick them together according to the chain rule. You could, of course, use the product rule here as well if you preferred. Either is fine. So du dx should give me cos x, and dy du should give me 8u. And the chain rule says du dx times dy du. So we're going to multiply those two terms together. So cos x times 8u is going to be 8 cos x sine x. Now, if I relate that to my original question, where I have my value of u at the top in black there, u was 4 sine squared x. That means that du by dx is 8 cos x sine x. So all this red part is kind of my side working. I'm doing that so I can differentiate 4 sine squared. It's kind of a rule within a rule. It does happen quite a bit with this subject. So my dy dx in the end, which is v du dx minus v du dx plus u dv dx. So v du dx is 8 cos x sine x cos 5x, it's quite long, plus v du dx, which is a minus in this case because of the minus 5. 4 times minus 5 will give me minus 20. Minus 20, and then a sine to the 5x, and a sine squared of x. And that question is finished. You could probably use some trigonometry proofs to simplify it, but I don't really want to. Now, the three products example, strap yourselves in. This is going to be a long one. For three products, you do two of the products in one go and one of the products at the end. So I'm going to start with the last one. This last bracket, v equals 1 minus 4x to the power of 9. If I differentiate that, that's quite straightforward. 9 times minus 4 gives me minus 36, and then my bracket to the power of 8. The other bit, I'm just going to kind of partition that off to the side of the page so I've got it hanging on there. I don't want to mix it up with anything else. Now, my u part, u equals x times 4x minus 3 to the power of 6. That is a product multiplied by a product. That is the product rule in the product rule. So I have to kind of do this part separately by itself, in much the same way I did the last example. So using this one, I'm going to say u equals x and v equals 4x minus 3 to the power of 6. Differentiate each bit separately. Du dx is 1. That was easy. And dv dx, 6 times 4 should give you 24 times 4x minus 3 to the power of 5. And then dy dx of this red version is v du dx plus u dv dx. That thing all over again, it comes up a lot. So v du dx is 1 times 4x minus 3 to the power of 6 plus 24x 4x minus 3 to the power of 5. And I would simplify that at this stage, or you're going to have something very messy for your final answer. So to simplify that, they have a 4x minus 3 to the power of 5 in common. That is their common factor. Take that out as a factor, 4x minus 3 to the power of 5. What's left from the first term then is 4x minus 3 to the power of 1, which is just 4x minus 3, and 24x. And then simplify what you've got. So you should have 4x minus 3 to the power of 5 times 28x minus 3. So that's the red section done. Now that means, going back to my original question, that black part at the top, u equals x minus 4x minus 3 to the power of 6. If you differentiate that, you get the answer we've just worked out. So 4x subtract 3 to the 5 by 28x minus 3. And now I've done all the parts for my product rule. So I'm going to kind of write it in here at the bottom. I've overspelled a little bit and went on to the next line here. So v du dx, it's quite long. There's my v, there's my du dx, put them together. So I put my v first. It doesn't really matter what order you put them in. 1 minus 4x to the power of 9 times my 4x minus 3 to the power of 5 times my 28x minus 3 plus plus u dv dx, which are those ones put together. So I've got x times that, x times minus 36. So I should have minus 36x times the two brackets that go with it, the 4x minus 3 and the 1 minus 4x. And again, I've kind of overspelled onto the next line here a little bit. I simply run out of room on my page. Very annoying. And if the question says differentiate it, you're done. That's your answer. But of course, you're probably going to have to simplify it. So I'm going to do that now as well. If I call 1 minus 4x A and 4x minus 3 B, and I rewrite my question, I'm going to have 28x minus 3 times A to the power of 9, B to the power of 5. Take away 36x, A to the power of 8, B to the power of 6. The whole point of writing it in terms of A and B is that it's easier to see how to factorize. If you don't write it in terms of A and B, it's still possible to do, of course. It just looks horrible because there's brackets all over the place. So keep out A and B first. Keep it in terms of A and B. Take out A to the 8, B to the 5, and that's what you should have left. At this point, I would leave the A to the 8, B to the 5 alone on the outside for now. And simplify what's inside the bracket. Inside the big bracket there, change A and B back into what they are. So A is 1 minus 4x, and B we said was 4x minus 3. Then I would simplify that larger bracket. So multiply everything out and compress it all down. Haven't touched the outside bit yet. So A to the 8, B to the 5. If you multiply out your brackets on the inside, you should have a 28x, subtract 112x squared, take away 3, plus 12x, minus 144x squared, plus 108x. It's quite long. And then for your final step, swap out A and B for your original brackets and simplify that larger bracket at the end. So A to the power of 8 is the same as 1 minus 4x to the power of 8. B to the power of 5 is 4x minus 3 to the power of 5. And that larger bracket, if you write it as a quadratic, you should have a negative 256x squared plus 148x minus 3. And that question is then done. It's been simplified fully. Hopefully you understand the product a little bit better. Feel free to click like and subscribe.